Hello everyone and welcome to CloudyML. So in this video, we are going to discuss about one of the very important interview question which was asked in TCS, and the similar questions were asked in several other interviews, including in IBM and Infosys as well. So this is the table where you are given the employee ID, employee name, the department ID in which the employee is working, the employee age and the salary drawn by each employee. Okay, and if you are following this series, you will understand this was the same table which we used in the previous video. Okay, so in this video, in this table actually, we have to get the nth largest salary from each department. So if we were asked, instead of each department from this entire table, to get the second largest salary, third largest salary, fourth largest salary. So it had a very simple query using an offset command. You could have used window function as well, but offset command, I think so it's simpler to use in that particular case. But in this case, the difficulty has increased a bit. Now what we have to do is we have to take each of the department, and we have to select all the employees from each of the department, and from those employees we have to select the employee who is drawing either the second largest salary, third largest salary, fourth largest salary. That is why I have written a simple statement that you have to find nth largest salary from each department. So if you are able to follow this problem properly, you would understand that in this case, there has to be a group. The group will be with respect to department ID. This is the first group. This is the second group. And this will be third group. Why this is important? Because you now know that don't have to look at your entire table at once. Instead, you have to look at these groups or these windows one by one and draw second largest, third largest, maximum salary out of this. So you must be getting the hint that you can use this very efficiently using the window function. Apart from window function also, if somebody is using the traditional SQL, they can use it using they can solve it using the self join. So we will look at both of this one by one in this problem statement. So let us go to my SQL workbench, and in this case I have already prepared or created the table and inserted the value, and you can look at this. You have got you have got this table here itself. You have 9 records. Each department has 3 records, so there are total 3 departments here. Now if somebody wants you to get the maximum salary, first of all, let us do this. If somebody says that if you have to get the maximum salary out of each department, in this case the query will be very simple. As you must have guessed, that what we have to do, we have to simply say select max of salary, and let's say I'm also including the department ID in this case, from employees, and you have to group. You have to simply use group by department ID. Okay, this is what you wanted. So if you run this, so you can see that you have maximum salary of 101, maximum salary of 60,000 in the department 101. For 102, you have maximum salary as 70,000. And for 103, your maximum salary is 92,000. Now, this is very simple. Now, the problem is how to get the second largest salary. How to get the second largest salary. Okay, so in this case, let us remove this department ID. I don't want any confusions as such. So what I can do is there can be a solution here where I can use a where clause and a subquery where salary is lesser than. This is also one of the approach, but this won't work in this case. But there are students who might think that okay, I can just modify this query a bit. Previously, I was using select max salary from employees group by department ID. That is all right. I can simply use a where clause here. And in this where clause, I can say that you have to select the max of salary from employees, where in this case, for each department, the department ID, you have to take where the department ID is equal to employees dot department ID. Now, this is one of the solution which people might think will work. Sometimes it works for some other situations, but in this situation, this won't work. Now, in this, what we are doing, uh, we are actually including a subquery instead. And what we are saying that for each of it is a dynamic subquery. So what will happen that you have to select the max salary from the department from the correct department ID. When you will run this, you will see you have got the 92,000 because in this case you have grouped the first grouping will be done by 101 department. In the second, it will be again asking for the second largest salary and all. But when you will run this query, when you will run this subquery, you will not get the correct result. This is not the correct result because you have you are getting 60,000, 70,000, and 68,000. And when you will run this, you should get 50,000, 65,000, and 68,000. So it is definitely not working. And why it is not working is because the order, the way the SQL work is, first, it will execute this command. First, where clause is executed. So when where clause will be executed, there is no grouping. There is no grouping from with respect to department ID. So it will simply use this directly. And what it will do, it will give the lesser salary with respect to the maximum salary, but it can give any lesser salary. That means if this is your table, ideally what you have to do, you have to group using, first of all, you have to make a group. Like this is first group, this is second group. Let's use a different color here. This is the second group, and this is the first. you have to you have to create the group, then only you will have to select the maximum salary and get the uh, second largest salary from there. But what the query is doing, it is obviously taking the first maximum salary from this, but it is returning first of all, it is taking 92,000 because it is like a maximum salary, and it is returning all the salary which is lesser than that. So grouping is not happening in the first place in this kind of query. So that is why this won't work. So this won't work. This won't work. Why this is not working? Because the maximum salary is taken from this statement like this particular department like this, which is 92,000. And the grouping is not happening. So first of all, where clause has been executed, and then grouping is done, which is not actually helping us out in this case. We are not getting the correct answer. Okay. For employee, for the department 3, you will be getting the actual salary, but all this where all the for the first department 101 and the second department, you will not be getting the correct salary. So what is the way around? The way around is to use a window function. And let us use the window function. Window function with respect to CTE will actually be working best in this case. So what you can do? So I will be using the temporary table because I want to select from that particular table. You can avoid this, but this is efficient. So if let's say I want to I want to actually create a temporary table with the name of ranked salaries. Let's say ranked salaries as, and I'll be using the window function. I'll say select ID, right? Then we have employee name, ID, employee name, department ID, and salary. Department ID and salary. And then what you have to do is after this, we have to use dense rank. We all know what a dense rank will do. What is the difference between a row, rank, and all these things? So in this case, in this particular case, let's take this example. The row number in this window function, a row number function, what it will do? It will simply use the row number. It will take one, and for this, and it will rank the salary. So what I can do is I can just take this here and I can just show you up here that this is like this. And if you can sort this in the descending order, or uh, smallest to largest, or largest to smallest, let's say like this. So what a row number will do? So what a row number will do? Row number will get all the values like this. Rank. Row number will bring all these values like this. This is a row number. Row number. What a rank function will do? Rank function will actually get the same thing like this, but there are two records with the same value, 60,000. So what it will do, 60,000 will be fifth rank, 60,000 will again be a fifth rank. But in this case, 55,000 instead of becoming sixth rank will remain as seventh rank. So you are skipping one number. And what will happen when you are working with dense rank? Dense rank actually follows this up. So what it will do, it will it will use the same thing. It will consider 60,000, both the 60,000 as a rank of 5, but 55,000 will become rank 6, 50,000 will become rank 7, and 45,000 will become rank 8. So this is what it is doing. So that is why we will be using dense rank instead of row or rank in this case. So this is our ideal case when you are working with ranking which have duplicate values. So this is where dense rank will be used. So what we can use is we can simply use a dense rank and dense rank, and then you need to use window function because we are looking only with respect to a subset of data, which is a group. For each department ID, we will be partitioning it. So department ID, this is the department ID, and then you also have to order by the salary from each department. Okay, with respect to descending. and you can name this as salary rank or sal rank, which I have run from employees. So from employees. So now what we have done, we have included the rank for each of the values, each of the records for each of the departments. So this has become my temporary table. And now what I can do, I can simply use this table and I can simply select department ID, comma, salary, and I can name this salary as, let's say, second largest salary. Second largest salary from from this table, which is called a ranked salaries, from this table which is called ranked salaries, and simply where the rank is equal to 2. So it's very simple and very efficient. Now you are only getting all the values with respect to rank 2. Okay, I got a error here in this case. Okay, it's not rank like this. I had named it as sal rank because I want to use where the sal rank is to. So I'll just be using this. So you can see now you are getting all the right value. In this case, now this is very dynamic. So what you have to do in this case, if you want another salary, like you want third salary, fourth salary, fifth salary, sixth salary, you can do, you just have to change this number and you are done. And what we are doing, we are creating each of the windows. We are not looking at the entire table in this case, but we are looking at each individual windows, and those windows or those groups are or are grouped with respect to department ID. So this is one way, and this is the most efficient way. But if you are very familiar with the self join and you can do that, no, you are very much a person who loves self join and you are very good at traditional SQL, then you can also use self join directly. What you can do, simply you can say select e1 dot department ID, and then you have to find the max of e1 dot salary. E1 will be my first table, as I'll be using the self join. E1 dot salary, and what you can do, from, you have to select these from employees, E1, and then you have to join, you have to do a self join uh, to the same employee table, employees E2, the same table where we are joining it, and you have to join on E1 dot department ID, of course. E1 department ID is equal to E2 dot department ID. Now, in this case, for each of the department, you will get 9 records. Just think about it, 9 records. And out of those 9 records, this part will give you 9 records. So if I can just execute this, or it will not get executed currently, uh, because you have to do a group by. So okay, I'll just use a group by here so that you can understand. Group by E1 dot department ID, comma, E2 dot department ID. Okay, E2 E2, E2 dot E1 dot salary. Sorry, not E1 dot salary. Okay, even, oh no, we don't require to do this group by salary, because we can just do it using department ID. So when I'll do this, you can look, we are getting each of the maximum salary. Okay, each of the maximum salary. And now in this case, if I want the second largest salary, so in this case, what I can do, I can include a condition, and I can include a condition and say, and as I said previously, you'll get the 9 records. If I can just remove this 1 second, and I'll just press star. And when you will look at the result, you will find, you can find 101 coming 9 times, 102 coming 9, because this is how the self join works. You will be matching all the records. So 101 will be matched to 3101. So you have 3101 in employee table, uh, uh, employee table with department ID 101. So there will be total 9 records. So this is where you have to understand how the self join works. So it requires a good knowledge of self join to do that. So once you do this, so now out of those 9 records for each department, from that you have to select all those records where E1 dot salary will be less than E2 dot salary. E1 dot salary will be less than E2 dot salary, and then you can simply use a group by E1 dot department ID. So this is a simple query with respect to a self join, and you will be getting the same answer. Same answer. In this case, you will be getting the same answer like this. You can look at this. You are also getting the same answer using this maximum salary. So this is a very simple. If you actually have a very good idea about how the self join will is working, in that case, this will be a very good query to work with, because what you are doing, you are actually getting all the 9 records, and from those 9 records, you are only selecting those records whose salary is greater than E2 dot salary. Okay, and there will be only one record which will be a second largest record when you will be working with this query. So just look at this. And also, I gave you a task. If you can use this self join. Task is use the self join method to get the third largest salary. Trust me, guys, you will learn a lot about it. So this is what we can actually figure out from this entire problem. Though in this problem, the efficient query, according to me, will be a window function query, but nonetheless, this this query, the self join query, is will be most important in case you are learning about SQL. For learning point of view, you should actually also give more focus to the self join. Otherwise, you will not be able to understand the concept of join. So this is where we will be ending this session, and I hope you like this video. And if you did, please like, share, and subscribe to CloudyML. Thank you.